You just can't get over it. You're going to go back. You're going to tell your friends. Well, it's the service or services that MPLS applications provide for us. That's the reason we use it. And one of those MPLS services that we could use for this scenario right here is called MPLS Layer 3 Virtual Private Networks. Now, by using a service like MPLS Layer 3 VPNs for our service provider network, we could do several things. We could keep all of the routing separate between customer A and customer B. We don't want them mingling or sharing each other's networks and routes. By keeping all of the routing separate or private from each other, then when Bob sends a packet to 172.16 something, it'll be going over to site 1 of customer B and not site 1 of customer A. So from a routing perspective, it's kept private. I'm going to put per customer here in our scenario. Now, if Bob is sending a packet over to site 1, and we have Lois up here who is sending a packet up to some device on her site 1, from customer A's perspective, I want you to take a look at R2 in our topology. From a service provider, our router, R2, guess what? It's carrying all of that traffic. It's carrying Lois's traffic going to site 1 and Bob's traffic going to customer B site 1. The reality is we don't have a separate physical network for each of our customers. But what we are doing is we are emulating or virtualizing, if you will, a logical network just for customer B and a separate logical network just for customer A. So let's you and I put ourselves in the customer's shoes just for a moment. If we are customer A, all we know about are the routes at our remote site and our local site. That's it. We don't know anything about customer B and vice versa. So from the customer perspective, customer A has their own, what they think, their own network between site 1 and site 2. While at the same time, customer B thinks they have their own network from site 1 to site 2. In reality, we're sharing the service provider network, including R2 forwarding all that traffic for both paths. So effectively, we virtualized our networks. We have a set of networks for customer A and another set of networks for customer B. And from a customer point of view, they are separate from each other. So if you have these virtual networks that are private from each other, for example, customer A and customer B, you could say that is a virtual private network. And that's what the VPN refers to in Layer 3 VPNs, virtual private networks. So one of the first things I want you to be aware of with this virtual private network as a Layer 3 VPN MPLS service or MPLS application is that it's not focused on cryptography. It's not focused on IPsec. Because that's what a lot of people think about when they see VPN. Oh, it must be running IPsec or SSL or some kind of encryption. No. The VPN in MPLS Layer 3 VPNs is all about creating these virtual networks, a set for customer A and a completely different set for customer B. That's the virtual networking part. And because they are separate and private from each other, that's the private portion. Simply because they are not shared or intermingled between customer A and customer B. They are private and separate from each other. Here's an example of a topology that's using MPLS Layer 3 VPNs. Again, that's just one of the many services that we could use that MPLS makes possible. So here we have Acme at site 1 and Acme at site 2. We've got CBT at site 1 and CBT at site 2. At site 1, Acme is using this address space, and at site 2, they're using this address space. And CBT, at their site 1, they happen to be using the same exact address space, and it's our responsibility as a service provider to make sure all that routing information keeps separate, or private, if you will, between those two customers. We don't want those routes accidentally to be mixed up between the two different customers. The other really cool benefit from an MPLS Layer 3 VPN solution is that inside of our core network, we don't have to have a physical network, one just for Acme, and we don't have to have another physical network just for CBT, and that's because we are virtualizing it. So logically, the traffic can flow through the network from site 1 of Acme to site 2 of Acme, and from site 1 of CBT to site 2 of CBT, but at the same time, we're going to separate the routing information and the forwarding information between Acme and CBT. And the cool thing about using a solution, an application like MPLS Layer 3 VPNs, is that it's very scalable. The other reality is we don't have to be a service provider to use it. We could just be a large enterprise network. We could have multiple sites, and we want to choose which sites have routing information and capability between the other sites. We could also implement that as an enterprise network for sites within our own company. All right, my friend, here's the action item I'd like you to do for this video. I'd like you to go back to the beginning of this video, take a look at those opt-out questions, and make sure you are comfortable in answering those questions now that we've taken a look at the content together. I have had a great time, and I'm glad that you joined me. I hope this has been informative for you, and I'd like to thank you for viewing. Is it possible to make forwarding decisions based on something other than IPv4 in an IPv4 network? The answer is absolutely yes. Let's begin. All right, everybody else, we are going to have a great time right here. Let's begin. I'd like you to imagine in your mind that it's a beautiful Tuesday afternoon. We just had a great lunch, and as we're walking back into our offices, we get stopped by a manager who says, "Do you have a moment? Could you explain to me how IP forwarding works?" And what's our answer going to be? Absolutely yes. We would love to walk you through that process. Probably the first thing we'd want to do is make sure we understand where we're starting with our manager. Now, if our manager already knew about the basic concept of an IP address, that an IP address has two components to it, there's a network portion and a host address portion. Starting from there, we could say, you know what, let's say that this router, R5, has the IP address of 5.5.5.5. Maybe that's a loopback address sitting on R5. And it's been advertised inside of a routing protocol so that the entire network knows how to reach 5.5.5.5. If an administrator sitting at R1 did a ping request over to 5.5.5.5, it would go something like this in an IP network. R1 would consider its routing table, and there is some caching involved with Cisco Express forwarding, and it would determine who should I forward this to. It's like hot potato. How do I get rid of this IP packet destined for 5.5.5.5? Based on its routing table, it's going to say I need to send this over to R2. In this topology, it's the only path. And R1 could have learned about R2 and R2's willingness to go ahead and forward to R5 through a routing protocol, such as OSPF or ISIS or some other IGP. So the packet, which let's say we're sourcing it from R1's loopback interface, from an IP perspective at layer 3, the packet would be sourced from 1.1.1.1 to 5.5.5.5. That would be the layer 3 header information. So as R1 forwards a frame forwarded to R2, R2 is going to take a look at that data, look at the layer 3 destination address of 5.5.5.5, and it's going to say, okay, now how do I play this game called hot potato? How do I forward this packet in the right direction? And based on its routing table, which is cached as part of Cisco Express forwarding, it's going to make a forwarding decision, and it's going to forward the packet this way. So it's going to re-encapsulate layer 2 information. In this case, we're on Ethernet with the layer 2 address of R3, but the source address will still be 1.1.1.1, and the destination is 5.5.5.5. Now, when R3 gets that packet, it's going to look at that destination IP address and say, oh my goodness, what do I do? It's going to play hot potato. Where do I forward this? And then again, based on its routing table, it's going to make a forwarding decision. It'll re-encapsulate at layer 2 with the correct layer 2 address of R4, which is the next hop. And the packet, if we looked at it right here, would still show source address of 1111, destination address of 5.5.5.5. And then when R4 gets it and looks at that layer 3 destination address, it has to make a decision. Oh my goodness, what do I do? And then based on its routing table as a foundation for how to forward packets, if it has a route, which hopefully it does, again, based on learning that route through some routing protocol, it would then go ahead and re-encapsulate the packet at layer 2 with the layer 2 address of its next hop, which is R5. And then R5, when he opens that up and starts de-encapsulating and looks at layer 3, R5 is going to say, whoa, that's my IP address. And then he'll continue to de-encapsulate. And if it was a ping request, for example, he would de-encapsulate it up to the ICMP portion. He would see it's an ICMP echo request and then very likely respond with an ICMP echo reply. In which case, we'd play that IP forwarding game all the way back down. Every router looking for 1.1.1.1, trying to make its forwarding decision. That is traditional IP routing as we know and love it. So if we grab any one of these routers, for example, let's grab R3 for a moment. R3 is just getting packet after packet, analyzing the layer 3 information, and making a forwarding decision based on that layer 3 information. Now, over a decade ago, I mean a long, long time ago, this took a lot of overhead. And you can imagine if you had an old router that was doing routing in software, where it had to think about and process every single one of those packets, the throughput may not be too high, especially if you look more than a decade ago when the hardware wasn't that great. If we had millions and millions of packets, it wouldn't be very efficient. Instead of using the layer 3 IP information to make forwarding decisions, why don't we give the routers something less to think about so they don't have to do all that processing? And that's